Hello, this is Dr. James Camp at Lee College in Baytown, Texas, and these are my comments on Chapter 7, Arrays and Vectors of Starting Out with C++ by Tony Gaddis. Okay, what is an array and why would we want to use one? Arrays are a single variable that holds multiple values. For example, if you wanted to store an array of student test scores, you could create, and the student test scores were all integer values, you could declare int tests square bracket 5. Okay, this sets aside a variable tests that points to a memory space, but this time instead of if we were to just say int tests, it would set aside this box to hold one integer. But in this case, by saying int tests and using the square bracket 5 notation, that sets up 5 memory boxes, all belonging to the same variable name, tests. Int is still, just as in normal variable declaration terminology, int is still the data type of the array. Tests is still the name of that variable location in memory. The square brackets with the 5 in the middle of them are what we call the size declarator, or the size declaration. It tells the computer how many elements you want in your array. So how many, in this case, how many test scores we would be studying. It would be storing in the array. The size of the array in memory is not 5. The size of the array in memory is the number of elements, 5, times the size of each element, and an int holds 4 bytes. Okay, so 5 times 4 bytes is 20 bytes. If you were to take a long double, which is 8 bytes, and set up an array of 10 of those, 8 bytes times 10 is an array of 80 bytes. Okay. It's common to use named constants in defining the size declaration. We can say const int size equals 5 and then int tests size, and then that just pulls the 5 that we declared for size in there. We'll see in a minute, we'll see as we keep going through this presentation, why that is useful, that we can keep referring to size over and over again as we keep using and accessing this array of tests, and then if we need to change how many test scores a student has, or how many students we're taking test scores for, or something like that, we can just change this one line in the program and everything else falls into place. Okay, so now that we've figured out how to create an array, let's talk about how to access array elements. Each element in an array is assigned a unique subscript. The subscripts always start at 0, not typically. The subscripts always start at 0, so for int myArray6, the subscripts would be 0, 1, 2, 3, 4, and 5 for positions for boxes 1 through 6. The last element subscript is always n-1 if n is the number of elements in the array. So for int myArray6, the subscripts would start at 0 and run to 6 minus 1 is 5. Array elements can be used anywhere that regular variables can be used. So you access an array element by the notation array name and then square bracket with the index number in it. So this is tests at index 0, so that's the first position in tests, and we're assigning it the value 79. Here we're taking tests at, again, index 0, and we're then passing it to cout, so we're outputting that variable. Cn, we're reading into tests at index 1. So again, we're using tests at index 1 anywhere a regular variable could be used. And we can even use multiple indexes on the same line. We can take tests at index 0 and tests at index 1, add them together, and stuff the result into tests at index 4. Not sure why we would want to do that if these really represent test scores, but we could do that. However, arrays must be accessed via individual elements. They may not be accessed as an entire array all at once. If you took tests and tried to output that to cout, that operation would fail. You have to output tests at a specific index. We'll see in a minute how to use loops to output the entire array if that's what you want to do. We can access the array elements one at a time by using the indexes, and so we can read in here 0, 1, 2, 3, 4, and 5. Okay. And then we can output 0, 1, 2, 3, 4, and 5 with a space between each, and we get this output statement there. And this is what happens when you do this. Hours at 0 gets the value 20, and then when we output hours at 0, we get the value 20. Hours at 3, 0, 1, 2, 3, hours at 3 gets the value 30, and when we output it 0, 1, 2, 3, we output 30. You can access an element with a constant or a literal subscript. Okay, so if we want to know the fourth test that a person took, we could just put tests at 3. Or if these aren't all tests one student took, if this is tests at, if each number represents a student ID number, we could have a constant representing my ID that was defined earlier in the program, and we can just access the element using the constant my ID. You can also use variables and other integer expressions as subscripts. So if we define I as holding the value 5, then we can get tests at I, and assuming we have at least 6 values in our list of tests, then that works. We can also do an actual integer expression in the square brackets. You can type size minus 1, and that will get you the last element in the array. Okay. You can use a loop to step through an array. This is actually really where arrays become useful. So far, all we've been doing is saying array at 1, array at 2, array at 3, array at 4, and then output array at 0, array at 1, array at 2, array at 3, array at 4. You might as well just define different variable names if you're going to do it that way. But where arrays come into their own, where it's useful to have one variable name that holds dozens of values, is that you can process them in a loop. So a conventional way to do this is for, and then you start your counting variable at 0. You count and as long as it's less than array size, because remember, it can't be equal to array size because the indexes run up to array size minus 1, and then you plus your way up through the array one count each time, and then we'll say assign a value to numbers at index count in each step through the array. Another way to process an array is to actually go backwards through it. This is less common, but it's totally doable. You set your index variable to array size -1 to start with, so that you start at the last element. And then as long as I is greater than or equal to 0, you keep processing the array and you minus it each time. So in this case, we're reading in numbers and then we're writing them back out kind of in reverse order, from last to first. Okay, this is just a closer look at the first loop, the more common way of doing it. The variable count starts at 0, which is the first valid subscript. It continues as long as it is less than array size, because array size is not a valid subscript value. It's the first invalid subscript value. Okay. What happens when you create an array? Do we initialize the values in all these memory boxes? As is typical with C++, if it's a global variable, the elements are all initialized to 0 by default, unless you tell it otherwise. If it's a local variable, we're just assigning that memory locally as part of a function, all of the elements remain uninitialized. But we usually want to avoid that. So arrays can be initialized with an initialization list. You optionally specify the size of the array because it can figure out the size of the array from your initialization list. And then you provide in curly brackets, not square brackets, a list of values to pass into this array. The values are stored in the array in the order in which they appear. So this is value 0, 1, 2, 3, and 4. Okay. And the initialization list cannot have more elements than the size that you've declared for the array. So we couldn't have another test score after this. This shows a initialization list for the number of days in all 12 of the months, and just a simple for loop that counts through those and prints out how many days each month has. Okay. It is possible, though uncommon to do so, for you to initialize part of an array and let the rest of the array be set to 0. So if we tell the computer that numbers has 7 elements, but we only initialize elements 0, 1, 2, and 3, then 0, 1, 2, and 3 get initialization values, and everything else gets set to 0. It's much more common when you're declaring an array with an initializer list to just leave the size out. Okay, have an empty size inside the brackets and just let the computer figure out how big the array is by counting the elements in your initialization list. So this one gets to be 0, 1, 2, and 3. And so we have an implicit 4 in these brackets, and we do end up creating an array of size 4. No bounds checking. Okay. If you've ever used a more modern language like Java or C#, or perhaps even Python, you'll have the experience of having tried to use a index in your array that was out of bounds and having gotten an error from the compiler or from the running program. C++ will not give you that error. Okay, when you use a value as an array subscript, okay, let's say we've got an array here that has 1, 2, 3, 4, 5, 6, 7 spaces in it, okay, and it's called my array, okay, of 7, okay. If I ask the computer for my array of 6, it's going to start at this position and just count forward 1, 2, 3, 4, 5, 6. That's why C++ arrays start at 0, is that 0 means you don't go forward any boxes, 6 means you go forward 6 boxes. But what if I asked for my array at position 7? It would count forward 1, 2, 3, 4, 5, 6, 7, and it would report whatever was in memory at that location. Or if I say my array at 7 equals 42, it would write 42 into that memory location. Well, what if I have another variable called myInt that's pointing at that memory location? Well, I've just written over myInt. I've just defined a new value for it without meaning to. So C++ does not check to make sure that you're using a valid subscript. So this just shows you that you can write and compile code that has a size of 3 but goes to a count of 5. Okay, and what would happen there is that you would write 100 at 0, 100 at 1, 100 at position 2, then you'd write 100 at what would be position 3 and what would be position 4, and if there are actual variables holding data in those locations, you've just overwritten those variables. Well, what if those variables are critical for your program? You can cause the program to crash. You can actually even lock up the computer. In older fashioned computers, modern computers have what's called memory sandboxing that keeps the memory in one program from messing with the memory in another program. But even so, it's possible to seriously mess up your program by using an invalid array subscript. So do not do that. A common way to do this is what's called an off by 1 error, and that's where you forget, for example, that the indexes run from 0 to size -1, and so you write your for loop to start at 1 and run to size, and all of the things that you stick into numbers, okay, will be off by 1. So if we make this array, and it's got memory boxes, and then this is box 99, that's box 0, 1, 98, okay. This loop will start by initializing box 1, and then we'll proceed on to box 2, and ... until it initializes 98, 99, and then tries to access position 100, which isn't actually part of the array, and so you end up writing over some box of memory here that does not belong to this array. Bad programming practice. Okay. Moving on, there is a unique for loop formation just for dealing with arrays, vectors, and other such collections of values. This came into being in C++ 11. So C++, as you know, was created in the 1980s. It took till 2011 for them to come up with this new for loop. So there are a lot of old C++ programs out there that were written before the 2011 standard that do not have this in them because it did not exist. But this is called a range-based for loop or a for each loop. And it iterates once. It's called a for each loop because it iterates once for each element in the array. Okay, so let's look at this. For type variable colon array. Okay, type is a type, so we might say int if we're continuing to work with integers here. Okay. Range variable is going to represent one value in the array, and it's going to step through the array holding a different value each time. So if this is our tests array that we've been working with, we might call the range variable test. Okay. So what this says is test gets one value from tests, then we run statement, then it gets the next value from tests, and then we run statement again, and it continues doing that until we run out of values in tests. The computer tracks for you how many values are in tests, so you no longer have to provide a length. You don't have to worry about off by one errors or out of bounds errors for your array because the computer handles all of the indexing and everything for you. So in this example, we create an array called numbers of type int. We stuff these values into it, and then we go int val numbers, and so the first value from numbers is copied to val. We see out that number. The second copy from numbers is copied to val. We see out that number, and our output will be 10, 20, 30, 40, 50. Okay. Now, one thing to note is that as the range-based for loop executes, its range variable gets only a copy of an array element. So you cannot use a range-based for loop to modify the array, to modify the contents of the array, unless you declare the range variable as a reference using an ampersand, like we've done for passing values by reference in functions. So in this case, where I want to modify the array, I used ampersand value. So this time, instead of copying numbers into value, we make value point to the first entry in numbers. We cin to val, then val points to the next entry in numbers. We cin val again, and we continue as long as there are positions in numbers to point to. Reference range variables can also be used with the auto keyword. I think actually all range variables in this range-based for loop can be used with the keyword auto. Auto will just be assumed to match the type of whatever's in the array. So if we're dealing with an array of ints, auto will set the type of and val to int. If we're dealing with an array of characters, it'll be char. If we're dealing with an array of doubles, it'll be double. The range-based for loop can be used in any situation where you need to step through the elements of an array, and you don't need to use the element subscripts. If, however, for some reason, like say you're sorting the array and you want to actually know what subscript you're on so that you can swap it with something at another subscript or something like that. For those situations, you would need to use a regular for loop. Okay. How do we process the contents of an array? Array elements, as we mentioned earlier, can be treated as ordinary variables. So you can say tests at index I plus plus. However, a lot of people make the mistake of putting tests at I plus plus, which simply increments the index variable, doesn't do anything to the value at tests at I. If we want to copy an array, unfortunately, C++ does not have a function that lets you say new tests equals tests. That just won't work. Instead, we have to go through one element at a time, I equals 0, I ask the array size I++, set new tests at I to tests at I. If you want to print the contents of an array, there is a special exception if your string is an array of characters. Okay, then that is an old-fashioned C-style string that we'll talk about in a future presentation. And if you've assigned it a C string value, then you can use it with the cout extraction operator or insertion operator. But this only works with that special situation of a C-style character array. If you were to try to do it with an array of int or an array of double, C++ would just laugh at you and tell you that you have to do it the for loop way. Okay, in C++ 11 or later, you can use the range-based for loop to display an array's contents. This is by far the easiest way to print an array, is for int val colon numbers cout val. You can use a simple loop to add the to sum up the array elements. You just declare a accumulator variable, sum in this case, sum plus equals tests at tnum, where tnum is test number, is starting at 0, counting up to less than size, plus plus each time. Once it's summed, assuming you know what size is, you can say sum divided by size is average. Keep in mind though, this is integer division. So, well, it's not because you did a double sum, but if you had previously, our tests had been an array of integers. So if this was an array of integers, you'd get an int divided by an int. So you do integer division. Okay. In C++ 11, you can make this a whole lot simpler with the range-based for loop. So for int val colon scores total plus equals val. Okay, and then again, average equals total over num scores. You can easily find the highest number in an array by stepping through you set highest to be numbers at 0, then you start your count at 1, go up as long as it's less than size, and at each one, if numbers at count is greater than highest, then you let highest be numbers at count. Okay. You could do the same thing with lowest, except you just change the direction of your greater than or less than operator. Okay, if you want to compare two arrays, you have to do it element by element. So if you want to find out if two arrays are equal, you set arrays equal to be true to start with, and then you step through, in this case they did a while loop, because as soon as you find out that the arrays aren't equal, you can stop counting. So if first array at count does not equal second array at count, arrays equal is false, that kicks you out of the while loop. And if otherwise, we count plus plus. Okay. If arrays are equal, we print the arrays are equal. If not, we print they're not equal. Okay. One fun trick with arrays is parallel arrays. Let's say that I wanted to keep track of not just a student's test score, but also their name. I could have an array of strings and an array of test scores, and if they both used the same index for the same student, then names at 0 would go with tests at 0. Okay. So parallel arrays are this word for two or more arrays that contain related data. So if I had character letter grades, let's call letters 5, and double GPAs 5, then this could be an array that holds A, B, A, C, D, and this could be their GPAs, 3.5, 3.2, 3.7, 2.8, 2.2. Okay, so that's the letter grade that they made in their most recent class and their GPA. Okay, and as long as I line up the subscripts with each other, then student 0 got an A and a 3.5. Student 3 got a C and a 2.8. Okay, here's an example of we're keeping track of student IDs, averages, and grade letters. Okay, here's an example of we're keeping track of hours each employee worked and the pay rate of each employee. And so employee 1 gets hours 10, pay rate 9.75, and so then when we calculate their gross pay, it's hours at index times pay rate at index. 10 times 9.75 is 97.50, right? Okay. The hours and pay rate arrays are related because we use the same subscript for the same employee. Employee number 1 is subscript 0. Employee number 3 is subscript 2. Employee number n would be subscript n minus 1. Okay, you can pass arrays as function arguments. Okay, so just use the array name, but you have to tell the function that you expect what you're passing to be an array. Okay, you don't have to tell it what size it's going to be, but you have to tell it that it's going to be an array. Now there's a problem that when you pass an array in C++, the array loses its size information. So if you want the function to know how many items are in that array, you have to add a parameter So you pass tests, and then you pass the size of tests. Okay, so it would look as show scores tests array size, and that tells the function how many scores to iterate through when it reads the array. Again, since C++ doesn't have any range checking on arrays, reporting this size is really important. So we pass the array numbers, and we pass the array size, and then it's able to go from index 0 to index less than size and output numbers at index for each one. Okay, array names and functions act like reference variables. So you're actually not passing a copy of the array, you're passing a pointer to the start of that array. That's why it loses its size information, but that also means that any changes to the array made in the function actually go back to the array in the calling function. So you want to be careful not to accidentally make changes in the array and find that your original calling array got changed. Okay, now by now you may be asking yourself, well, arrays are great, but what if I have more than one dimension of data? What if I want to keep track of rents in an apartment, not just by floor, but by which hallway within that floor? So I have hallway 1, 2, and 3, and I have floor 1, 2, 3, and 4. I need a two-dimensional array. So we can do this by defining, just using multiple square bracket notations in a row. So the blue one represents my rows, the purple one represents my columns, and it's kind of arbitrary that they decided rows goes first and columns go second, but that's the typical way of understanding it. Okay, so that means 0, 1, 2, 0, 1, 2, 0, 1, 2. And then if I look at my columns, 0, 1, 2, 3, 0, 1, 2, 3, and that way I can access 3 different rows and 4 different columns. And you access it, as this table indicates, by passing 2 subscripts, and then we can stuff 86 into subscript 2, subscript 2. Okay. An example would be a business that has divides its year into quarters and divisions, or it has, sorry, the company is divided into divisions and the yearly profits are divided into quarters. And so you want to know your sales by division and by quarter. So you put divisions first in this case and quarters second. Doesn't matter, you could have done it the other way, as long as you keep track of which one is which. Okay, so then you could step through all of the divisions and then step through all the quarters, and it prints to the user division div plus 1, because remember the subscripts are off by 1, quarter plus 1, and then asks the user to input sales by div and quarter. Okay, then it adds up, goes through all the divisions, goes through all the quarters, adds sales at div and quarter to total sales, and we get the total sales for the company. Okay, we could have summed up by division, we could have summed up by quarter instead. We don't have to add all the numbers together. Okay. Two-dimensional arrays are initialized row by row. So if you have rows, columns, you're going to specify the 2 columns of row 1, then you're going to specify the 2 columns of row 2, each in its own set of curly brackets. Okay. You can still use an array name as an argument in a function call. This time, however, while you can leave the number of rows empty, you have to tell it how many columns. Okay. So in this case, we're saying that our 2-dimensional array must always have the same number of columns, but can have as many rows as we want, and we'll pass rows in as a variable to tell the function how many. So table 1 rows is 3, table 2 rows is 4, and so we'll pass 3 and then 4 to the function when we ask it to show the array. Okay, we can sum all the elements in a 2-dimensional array by just walking through all the rows and then all the columns, and then just display the total. Or we can sum just the rows, for example, by we go through the rows, and then within a row we go through the columns and get a total, and then maybe we want the average. So the score for student row +1, because again the indexes are all off by 1, is the average we calculated for that row, and then we go back and do the whole thing again for the next row. Okay, set the total back to 0 and then start summing up that row, the next row. We could do the same thing with columns. Okay, this time you start with the columns, and then you proceed through the rows and total them up and get the average and say class average for test column +1 is average. Really funny thing about C is that you can have as many dimensions to your array as you want. Okay, you just keep adding square brackets. You can have a 3-dimensional array, which represents sort of a 3-dimensional entity in the real world, right? You could have a 4-dimensional array. Maybe you add the 4th dimension of time, as they indicate through this. You have dimensions along, X, Y, Z, and time. Okay, but they don't even have to represent those. You could have a company with 3 divisions and 4 quarters and 3 product lines and 4 international sales zones or something. You can come up with all sorts of ways that you might need more than 2 dimensions, and they don't always have to correspond to the XYZ reality of 3 dimensions. Okay, finally, we want to introduce another way of doing arrays, which is, in my opinion, a better way of doing arrays, because this uses the object-oriented nature of C++ to store information about the array in the array itself. It makes the array, or vector as we're going to call it, dynamically sized. It can get bigger or smaller as you go through the program. You don't have to know ahead of time at the very beginning of the program how many test scores you might have or how many students you might have. Okay, this is defined in something that C++ calls the STL, or Standard Template Library. Okay. Templates in C++ are data structures that have a data type, that have a structure type, a template type, and then in what we call diamond notation, they have a data type. So this is, you read this as vector of int. It's a vector of type int, and the vector name is scores. Okay. You can do this, and you can, how many spaces does scores have at this point? It has none. Well, what's the use of an array that has no space in it? Well, the STL vector automatically adds space as more is needed. So you don't need to determine the size at the definition. And in fact, the size of scores would not be 0. It would set up a certain amount of space, maybe 8 or 10 slots in the vector, so that you would have some amount of space to start filling up. But as soon as more space is needed, the vector object rearranges the memory to add more space to itself. And the cool thing about vector is you can still use the square brackets to access elements. So you could still say scores at 2 equals 32, or cout scores at 4. Okay, those are still legit statements. Okay, some syntax: you have to pound include vector to get the vector library. You have to declare the vector with this diamond bracket and a legitimate C++ type. Okay, it can be any type. You can have a vector of string, you can have a vector of int, you can have a vector of double. If you create your own type called whatchamacallit, you can have a vector of whatchamacallit. Okay, but you have to put a valid C++ type in the brackets. You can't just have a vector. And then you have to give it a name. Okay, some cool things you can do. You can set the initial size to 30, and it'll just create 30 empty boxes. You can set the initial size to 30 and then initialize all elements to a certain value. So if we want 30 boxes and they're all full of 0, we can do that. If we want 30 boxes and they're all full of 100, have 30 students, give them all a 100 on this assignment, we can do that. You can also copy from one vector into another, as long as you're creating the new vector brand new at that moment. Okay, so vector int finals, this means we're initializing it with all the values from scores. So there is a way to copy vectors, even though there wasn't a way to copy arrays. You can initialize a vector with a list of values. You don't put the equal sign in, you just put initializer notation. Okay, just as you can say int num 42, okay, and initialize num to 42, you can say vector of int numbers and then curly brackets with your list of numbers. There are, you can add to a vector by using the pushback member function. So like any member function, you take the name of the object, dot notation, pushback 75. Okay. Push and pop are, come from data structure terminology. If you have a stack of values, you push things onto the stack and you pop them back off. So we're pushing onto the vector, but we're pushing on the back side. There's also a push front, I believe. There's a size member function that the vector remembers how big it is. Okay, so you can call scores.size and find out how many scores are currently in that vector. You can use the popback member function to remove the last element from a vector. So not only can vectors grow to accumulate more values, they can also shrink as well. You can remove the entire, you can clear the entire contents of the vector with the word clear, and you can check to see if the vector is empty. Okay, so you could say while not scores.empty, see out scores.popback. Okay, and that'll pop the last value off of scores, output it to the terminal, and keep going until you've emptied out the scores array or vector. Okay. You can use a range-based for loop with a vector. Obviously, if you can do it with an array, you should be able to do it with a vector. So int val gets each number in a row, cout val, and you get your numbers. Okay, there's some other useful member functions. @I works the same as bracket I, except it has range checking. Okay, so @I will actually return an error if you try to exceed the bounds of the vector. Bracket I will not. Capacity tells you not the size of the vector, but how much memory space the vector has set aside for it. So sometimes those are equal, but sometimes capacity is bigger. Sometimes the vector has set aside a little extra room so that you can add some more values to it. You can reverse the orders in a vector. You can resize the vector. So that adjusts, resize adjusts capacity. Okay. So if you have a 10 element vector and you want to make sure it holds 20, you can resize 20, okay? And then the new elements will be initialized to whatever your val is, okay? And you can swap two vectors. This is kind of a cool thing. If you want to exchange the values of vec1 and vec2, you can swap them. Okay. And somewhere in there, I was supposed to mention that you can pass a vector to a function and not lose its size information. So because you can call the dot size member function and get the size value, vectors can be passed to functions without having to specify their size. Okay, so that concludes this lecture. Up next, we'll talk briefly about a couple of important things to do with arrays and vectors, that is searching through them and sorting them. That'll be a fairly short lecture, and then we'll move on to some more advanced topics in C++. Okay, thank you for your attention. As always, if you think you learned something, leave me a like and leave me your comments in the comments section.